Hi everyone, you're watching the exponential growth and decay function note video. In this video, we are going to talk about exponential growth and decay, and we are going to be writing equations and also interpreting the parts of exponential functions in context. So we're going to get started, but the first couple of things that I want you to write down is that we're going to be comparing to 100% a lot. If you can take that out of this video, that is one of the main things that I want you to take from it. So let's not forget to write that down. Also, let's talk about the structure of an exponential equation that we've dealt with this unit. Y is equal to A, the initial value, times B, the multiplier, to the x power. Okay, let's dive right in. Example number 1. So we have fruit flies. They are growing at a constant rate of 2.5% every hour, and that the initial population of fruit flies is 28 flies. Okay, so we have some pretty important information in here. They are also giving us the units, P of H after H hours. So they gave us our X and our Y value. So let's begin. P of H, so the population of fruit flies, is going to equal the initial value, which is 28, times the multiplier. But our multiplier here is a percent, and it's also a percent growth. So the first thing that we have to do is compare to 100%. So off to the side, I'm going to write 100% because our fruit flies are, the population is getting bigger, we will add. So 100 plus 20.5% is 120.5%. If I write that as a decimal, it is 1.205, and this is to the H power. And there's our equation. Notice how I used correct units. Let's see this again. So we're draining water out of a pool, and the depth of the water is going to be decreasing at a constant rate of 28% per day, and the depth of the water at the beginning is 40 feet. Let's write an equation using these units that they give us. Okay? So in this case, it's W of D, the water, is equal to the initial value, there's our 40, times our multiplier, which we have to get ourselves. We're going to compare to 100% again. Notice how I plopped that 100% right down, only we're losing 28%. So 100 minus 28% is 72%. Again, we have to write this as a decimal, so we have to convert it by moving the decimal place over 2 spaces to the left and get 0.72. In this case, it's to the D power. Now let's answer the question. It says, how many feet of water will remain to the nearest whole number after 9 days? So we're looking at the days to be 9. So W of 9 is going to equal 40 times 0.72 to the 9th power. Let's take out our calculators. So 40 times 0.72 to the 9th power is 2.0799, and it said after how many days. So, how many feet of water are going to remain after 9 days? About 2 feet. Because we're going to round to the nearest whole number. Okay, number 3. So here we are now given a function. So they gave us the function in this example, and it represents some beetle in South Africa where X is measured in years. So what we need to do is explain what 500 and 0.98 mean in the context of the problem. Well, most students always get the initial value right, which is there's initially 500 beetles. So there are initially 500 beetles. Okay. But this is where the 0.98 kind of throws us off, because a lot of times people want to say that 0.98 is like the number that's what it means, when in actuality we have to compare that to 100%. We're not going to give up on that comparing to 100% with that multiplier. So I'm going to take this guy right down here. 0.98 as a percent is 0.98, or excuse me, is 98%, right? Because we need to move the decimal 2 spaces in the opposite direction, because we got to get it back into a percent. We got to talk about percent growth or decay. A lot of you probably looked at this and said, oh, the beetles, the population of the beetles, it's decreasing because it's smaller than 1. And you are right. How much smaller than 1, you might ask? Well, compare it to 100%. 98% minus 100% is negative 2%. So what does 0.98 mean? This means every what? Every day, month, year, every year. And I'm going to underline that the beetle population I'm spelling it wrong. Decreases by 2%. Okay, let's see this again, how this might look in a different type of question. So the value of a home can be represented by this v of t function, where t is in time, in years. So we need to explain what the 120,000 and the 1.018 mean in the context of the problem. Well, many of you probably already know that this number out in front is the initial value. So what does that mean? There were initially, or the value, right? This is what we're talking about here. The value of the home is $120,000 at the start. Initially, potato, potato. Okay, now let's talk about the 1.018. So the 1.018, compare it to 100. I hope that that's embedded in your brains at this point. 101.8%. Many of you probably already noticed that that was bigger than 1 whole, so that means we have some growth happening here. That's cool. So compare it to 100% and see what's left over. 1.8%. So let's talk about this as a rate. This is kind of like a slope. So every what? Every year, the what? The value of the house. What's happening? Increases, because it was bigger than 1 or 100%, by 1.8%.